Hello, everyone. Welcome to Techie. There's this idea that AI is evolving from just another tool into the actual power grid of our digital world. And honestly, it's a pretty great analogy. But to really get a handle on this new grid, you gotta speak the language, right? So in this explainer, we're gonna break down 10 super important AI terms. They'll take you from what AI can do right now to where it's headed. Ready? Let's dive in. All right, first up, let's talk about the AI creators. These are the systems that are all about making brand new, original stuff. And that brings us to our very first term, generative AI. So you know how older AI was mostly about analyzing or sorting data? Well, generative AI is totally different. It's like a digital artist or writer. It soaks up massive amounts of information and then uses what it's learned to create something completely new. We're talking about anything from drafting an email for you to painting a picture or even composing a piece of music. Okay, so you're probably wondering, where do large language models, LLMs, fit in? It's a great question. Think of it like this. Generative AI is the whole broad category of creative AI. An LLM is just one specific type of that, one that's a genius when it comes to text. So yeah, every LLM is a kind of generative AI, but not the other way around. You've got other models that are built to whip up images or videos or even computer code. But how does an LLM actually work? Well, when you peel back all the layers of complexity, the core idea is actually kind of simple. At its heart, an LLM is a super sophisticated prediction machine. It takes your prompt and just predicts the most likely next word. Then it does it again for the next word, and the next, and so on. It just strings them all together, one word at a time, to build out a complete, logical response. Now, there's a catch. As these models get bigger and bigger, they get crazy expensive to run. And that's where this really clever idea called mixture of experts, or MOE, comes into play. Imagine instead of your whole brain lighting up for every single thought, you only use the specific parts you needed. That's MOE. It has a bunch of specialized experts inside, and for any given task, it only calls on the few it actually needs. Just look at the numbers here. A standard model like Llama 2 has to fire up all 7 billion of its parameters every single time. But a slick MOE model like Mixtral, it might have a whopping 47 billion parameters total, but for any one request, it only activates a fraction of them, like 13 billion. It's a game changer for efficiency. Okay, so we've seen how AI can create stuff, but what if we need it to do more than just write? What if we need it to actually think? Well, that's the next big step. AI that can reason through problems. And this leads us to our next term, large reasoning models, or LRMs. You can think of these as a souped-up version of an LLM. Instead of just blurting out an answer, an LRM is trained to show its work. It actually builds an internal chain of thought, breaking down a complicated problem into smaller, logical steps before it gives you the final answer. So what really makes them different? Well, it's all in the training. They're fed a diet of problems that have clear right and wrong answers. Think math or coding. The model then gets rewarded for figuring out the correct step-by-step path to get to that right answer. You know when you see that little thinking bubble in a chatbot? Yeah, that's a pretty good sign an LRM is busy behind the scenes, mapping out its reasoning before it talks to you. All right, hold on, because this is where we take a huge leap. We've gone from creating to thinking. Now we're going from thinking to doing. Welcome to the seriously cool world of agentic AI. And this comparison really spells out the difference. A generative AI, like we've been talking about, is reactive. It just sits there and waits for you to give it a prompt. But an agentic AI, it's proactive. You don't give it step-by-step instructions. You just give it a goal, like, hey, plan my entire trip to Tokyo. The AI agent then goes, okay, got it, and starts figuring out all the steps, finding the right tools, and actually doing the work, all while you kick back. It's a total shift from just giving you an output to managing a whole project. So how does one of these agents actually get things done? It's all based on this constant 4-step loop. First, it perceives. It looks around and gathers info. Then it reasons. It makes a plan. Next, it acts. It actually executes the plan using different tools and apps. And finally, and this is the key part, it learns from what happened so it can do better next time. It just keeps running through this cycle over and over, which is what makes it so autonomous. Okay, but wait. For an agent to actually do stuff in the real world, it needs to connect to all your apps and data, right? And that's a massive security and tech headache. This is exactly the problem that the Model Context Protocol, or MCP, is trying to solve. You can think of it like a universal adapter or a secure translator. It's an open standard that lets these AI models talk to all sorts of external tools like your calendar, your email, booking sites, safely and securely. All right, let's tackle one of the biggest problems with a lot of these models. Their knowledge is basically stuck in the past, frozen at the time they were trained. So the big question is, how do we give AI a better memory, one that's actually up to date? I mean, think about it. If a model's last update was a year ago, how on earth is it supposed to know about anything that's happened since then? Or what about your own private company files? It can't. Well, our next two terms are the solution to this exact challenge. Part one of the solution is something called a vector database. Now, a normal database is like a book index. It finds exact keywords. A vector database is totally different. It's more like a library where all the books are organized by their ideas and meanings. It turns all kinds of content into a string of numbers called embeddings, and then it groups similar concepts together. So you could search for something like reasons our team is unhappy, and it's smart enough to pull up a document about burnout and job dissatisfaction, even if your exact words aren't in it. Pretty cool, right? And that brings us to the process that uses these special databases, Retrieval Augmented Generation, or RAG for short. It's a clever little workflow. Here's how it goes. You ask the AI a question, but before the AI answers, the system first retrieves fresh, relevant info from that vector database. Then it augments or adds that new information to your original question. Then, and only then, does it send the whole package to the LLM to generate an answer. The end result? An answer that's based on current, factual data, which seriously cuts down on those weird mistakes or hallucinations. So we've covered a ton of the tech that's here today. But for our last couple of terms, let's shift gears and look way out into the future. We're getting into theoretical territory here, but these are the concepts that are driving the whole field forward. First, we have artificial general intelligence, or AGI. For a lot of researchers, this is the holy grail. AGI is all about creating an AI that has the same kind of flexible, learn-anything intelligence that we humans have. It wouldn't just be a master at chess or writing code. It could learn and adapt to pretty much any task or problem you throw at it, just like a person. Then there's the next step. Artificial superintelligence, or ASI. This is still purely hypothetical, but it's the idea of an AI that doesn't just match human intelligence, it leaves it in the dust. We're talking about an intelligence that would be smarter than the most brilliant human minds in basically every single field, from science and creativity to, well, everything. So if you want to remember the key difference, it's really this simple. AGI is about reaching parity. It wants to be as smart as a human. ASI is about transcendence. It's about becoming something far, far smarter than us, maybe even in ways we can't fully grasp. And there you have it. That's our quick tour of 10 really important AI terms. We went all the way from the creative tools we're using right now to the futuristic ideas that are shaping tomorrow. It's a pretty wild ride, isn't it? Hey, if you enjoyed this explainer and learned something new, do us a favor and hit that like button. And of course, subscribe so you don't miss our next one. We'd also love to hear from you. Drop a comment below and let us know what AI topic you want us to break down next. So we'll leave you with this one last thought to chew on. We've seen AI as a creator, a thinker, and a doer. It's really starting to feel like a new kind of partner in our world. So the big question is, what role should it play next? What do you think? Thanks so much for watching.